Something enormous just slammed into Earth. Not an asteroid, not a missile, not something made by humans. It came from the Sunday. In January 2026, Earth was hit by the strongest solar radiation storm in 23 years, powerful enough to flood the planet with charged particles, disrupt space systems, and light up the night sky in places that almost never see auroras. Scientists were watching it in real time. Satellites braced for impact. Airlines adjusted flight paths. And for a brief moment, Earth's magnetic shield was pushed to its limits. So what exactly happened? How dangerous was it? And why are scientists saying events like this could become more common? Let's break it down. On the 18th of January 2026, the Sun unleashed a powerful X-class solar flare, officially classified as an X1.9 flare. To put that in perspective, X-class flares are the strongest category of solar flares. Each step up the X scale represents a tenfold increase in energy. This flare was strong enough to launch a massive cloud of solar plasma directly toward Earth. That cloud is known as a coronal mass ejection, or CME. Within about 24 hours, the CME reached Earth. On January 19, instruments across the globe detected the impact as Earth's magnetic field absorbed the shock. NOAA's Space Weather Prediction Center immediately issued alerts. What followed was one of the most intense space weather events since the early 2000s. NOAA classifies solar storms using two main scales: Solar Radiation Storm Scale, S scale. This storm reached S4 severe. That is one level below the maximum rating. According to NOAA, S4 storms are rare. They can expose astronauts and high-altitude flights to increased radiation. They can damage satellites and interfere with spacecraft electronics. The last time Earth experienced a solar radiation storm this intense was during the Halloween solar storms of 2003. That's where the strongest in 23 years headline comes from, and in this case, it's accurate for radiation intensity. Geomagnetic storm scale, G scale. The storm also reached G4, severe geomagnetic levels. G4 storms can disrupt satellite navigation, interfere with radio communications, cause power grid irregularities in extreme cases. It's important to note, this storm did not exceed the May 2024 G5 geomagnetic storm, but its radiation intensity was higher than anything seen since 2003. One of the clearest signs something extraordinary was happening came after sunset. Auroras normally confined to polar regions suddenly appeared far from the Arctic and Antarctic. Verified reports confirmed auroras visible in Southern California, Alabama, Georgia, New Mexico, large parts of Europe, including France and Germany. This happens when solar particles penetrate deeper into Earth's magnetic field, colliding with atmospheric gases and producing glowing colors in the sky. Events strong enough to push auroras this far south are extremely rare. For many observers, it was a once-in-a-lifetime sight. For scientists, it was a reminder of how powerful the sun truly is. While most people experience this storm as a beautiful light show, behind the scenes, precautions were taken. Satellite operators closely monitored systems for radiation damage, signal interference, orbital drag from atmospheric expansion. No major satellite failures were publicly reported, a sign that modern shielding and forecasting worked. Astronauts aboard the International Space Station were advised to remain in better shielded areas during peak radiation. At S4 levels, radiation exposure becomes a real concern outside Earth's atmosphere. Aviation. High altitude and polar flights faced increased radiation exposure, possible communication disruptions. Some routes were adjusted as a precaution. This is exactly why space weather forecasting exists. This storm didn't come out of nowhere. The sun operates on an approximately 11-year cycle of activity. We are currently near the solar maximum of solar cycle 25, the period when sunspots increase, solar flares become more frequent, CMEs are more likely to occur. Scientists had predicted increased activity during this phase, but the intensity and frequency of recent storms have exceeded many early expectations. May 2024 delivered historic geomagnetic storms. January 2026 delivered historic radiation levels. And solar maximum hasn't fully ended yet. So just how close did this come to being a real disaster? Closer than many people realize. According to space weather scientists, the January 2026 storm sat right below the threshold, where serious infrastructure damage becomes likely. The difference between a spectacular aurora and a technological crisis often comes down to timing, angle, and magnetic alignment. Earth's magnetic field didn't just absorb the storm, it deflected it at a favorable angle. Had the coronal mass ejection arrived with a stronger southward magnetic orientation, the interaction would have been far more violent. In that scenario, charged particles can punch deeper into Earth's magnetosphere, overwhelming defenses designed to protect satellites and power systems. This isn't theoretical. We know exactly what stronger solar storms can do because it has already happened. In 1859, during the Carrington event, a solar storm far more powerful than this one hit Earth. At the time, global technology was limited to telegraph systems, and even those failed catastrophically. Operators reported sparks flying from equipment, telegraph lines catching fire, and messages being sent with the power disconnected because Earth itself had become electrically charged. If a Carrington-level event happened today, the consequences would be far more severe. Modern studies estimate that such an event could disable large portions of satellite networks, knock out GPS and navigation systems, disrupt global communications, cause long-lasting power grid failures in some regions. In 1989, a much smaller geomagnetic storm than this one still managed to collapse Quebec's power grid, leaving millions without electricity for hours. January 2026 didn't cross that line, but it came close enough to remind scientists how narrow the margin really is. And that margin is shrinking as our dependence on technology grows. The January 2026 solar storm didn't bring down power grids. It didn't cripple satellites. It didn't shut the world off. But that's not the point. The real takeaway is this: Earth was tested. For a brief period, our planet stood between modern civilization and a blast of energy powerful enough to disrupt systems humans rely on every single day. This time, Earth's magnetic field held. This time, the angle was favorable. This time, preparation and forecasting worked. But the sun is entering, not leaving a highly active phase. Solar cycle 25 is still unfolding, and scientists expect elevated activity to continue for months, possibly years. More flares, more CMEs, more close calls. What makes this moment different from the past isn't the Sunday. It's us. Humanity has built a civilization that stretches into space satellites, space stations, GPS, global networks, all vulnerable to forces that originate 150 million kilometers away. The January 2026 storm was not a warning siren. It was a stress test. A reminder that the greatest natural threats don't always come from the ground beneath our feet. Sometimes they come from the star that gives us life. And next time, the outcome may depend not on luck, but on how ready we are.